need to find the position of the particle at time t equals 1. The problem is I cannot... How many of you, your first option is to anti-differentiate, find a c, use that equation? I can't integrate this by hand, which means coming up with an equation is quite difficult. Your TI-89 can't even integrate this with an equation, Joseph said. He said it just pops the integral back out at you, which means you can't do it. However, we know we can do any integral from endpoint to endpoint, and your calculator can approximate that. Even your TI-84 can do that, because your TI-84 is not using anti-differentiation to find an integral. What is your TI-84 using? Anyone know? Area. It's doing infinitely many rectangles and Riemann sums. It's a really stupid fast calculator. It doesn't know what it's doing, but it's doing whatever that is really fast. And so it can add up a bunch of rectangles. It can't actually anti-differentiate. But that's good for us on this problem, because it turns out no one can anti-differentiate that. So I need to figure out what definite integral I could set up to help me find the position at time 1, which brings me to an old equation. What old equation am I thinking of? Good. F of b equals f of a plus the integral from a to b of f of f prime of t dt. Right? Starting point, or the ending point, equals the starting point plus the accumulated values. Yes.
Is that the function b?
The number f of b. Like
small f.
Like f of 2. Oh, that's a small f.
So that's the small f.
Yeah. Right, because I have f prime. Now you could rewrite this with a big F there if you didn't put f prime. Tomato, tomato. So, I do need my position for x and for y. So I need my position at my x position at time 1 and my y position at time 1. My x position at time 1. Well, what do I know? I know my position at time 2, right? Everyone agree with that? There are a couple ways you could do this. You could just follow the formula as it sits, or if you don't like the big number being on bottom and the small number being on top, you can rewrite the formula to fit that. I'll show you both and what I mean by that. Just following the formula, I just put x of 2 here plus the integral. I do have to be careful though, because remember this is ending point. The 1 is the ending point. So I have to put the 1 on top. I have to integrate that backwards. Calculator can handle that, so that's fine. You don't have to rearrange it. And let me show you another way to do it. If you can't remember that formula, what you can remember is this formula. Because I made you, right? On a master exam at least once. So this is the fundamental theorem of calculus, right? Well, if I want to find f of a, for example, right, I can do the integral, subtract f of b, and divide by -1. So if you prefer doing the algebra and that formula, that works great. Or if you prefer using the ending point equals starting point plus the integral, that works great as well. You will land in the exact same spot. Because when you reverse limits, it gives you a negative integral. Everyone know what I mean by that? So. Do we remember learning this a long time ago? Okay. So x at time 1 is x at time 2, which was 1. plus the integral from 2 to 1 of sine of t cubed dt. And I would use my TI-89 or my TI-84, either way, and type that whole thing in.
Negative. What's the
0.782.
x of 1 if it's in
Does need to be in radians. Okay. Check if you have a disagreement, let me know. Does everyone know how to do a definite integral in your 89? After the comma x, do comma 1 or comma 2, comma 1. Y1 would be, what is it? Is it 4? Is the point 4? Plus the integral from 2 to 1 of y prime of t dt. And what do we get?
we're supposed to use
So before we go on, because this is a formula that even AB calculus students kind of struggle with using, and it's one that y'all resist a lot because you like the plus C and just finding C. Even AB students do the same thing. So I just want to make sure we have no questions on that formula. Any clarification needed?
Yeah, why are the limits
2 to 1. So we're still going from the same time values. So this gives me, this integral here gives me the displacement on y. Is that, so are you asking why they're the same as the x? Is that what you're asking? Or just in general, why is it 2 to 1? Okay, in general, why is it 2 to 1? We know the value at 2. And so I'm kind of unaccumulating. I want to go backwards to time 1. And I've lost some. So the integral from 2 to 1 gives me the, it essentially subtracts my accumulated area in my position, which if I'm doing the area under velocity, I get distance. So that gives me the displacement from 2 back to 1. And then I'm adding that to my initial value, which was where I was at 2. So I'm taking where I was at 2 and subtracting the accumulation, essentially.
why is the one on top?
Good question. In the formula, if I were just to rewrite this, I would get f of b equals f of a plus the integral from a to b, right? But what do you notice about the a's or the b's? Isn't that the top? So it has to be the top to make the, if you're just straight using the formula, your f of b has to be the ending value on your integral. Okay. Does that make sense? Yes. Okay. The other thought process, if you want to think physicsy for a moment, I'm going backwards because I'm at 2. I want to know where I was at 1.
Okay.
So I'm unaccumulating instead of accumulating. That's probably more information than you need, but one of those two options.
If it was asking for like time equals 3,
Then you would do
it would be from 1.
1 to 3, right?
Okay.
Or yeah,
1 to 3.
no,
2 to 3.
2 to 3.
Yeah,
Yeah.
I know what you mean. But with like the x, would the x1 and the x2 still be the same spot?
No, because you'd be looking for x of 3.
But
That would be what you'd be trying to find.
Okay, so what is the x of 1?
It is what I'm trying to find. The position at time 1.
Okay, got it.
And so the way this formula works generally is the 1 is bigger than the 2.
Right.
This one it's wrong,
Okay.
which is it hurts our brains a lot more than it hurts the formula's brain.
Right.
It hurts our brain that
Just
we're
like figure out
switching
what
them.
does.
But if you think about it truly, remember when we learned this formula, we didn't use A and B, and there was a reason we didn't use A and B.
Right.
We used ending point equals the start point plus the integral from start to end. Well, there's a reason I used that wording, because I knew that they will change those around.
Okay.
So our ending point is at 1. I want to know the position at time 1.
Okay.
Given the start point, they gave me time 2 from start to end.
Got it.
Does that make sense?
Or you could just use minus.
Or you could rearrange the formula. Yeah. You have lots of options. Surely in all of this discussion, someone has calculated y of 1. Any questions about and I don't mind spending some time on that because it's 1, good review, and 2, good for this. But I don't mind those questions, so if you have any more, I would love to answer them. We feel better about that formula a little bit. I know we are always hesitant to use it. Okay, 1 more problem for the day, and we will be finished. This is a real AP problem. So you can kind of get to see a real open response AP problem on vectors. Remember vector worksheet 1 and 2 and the multiple choice, it's like 4 problems, are due on Tuesday. And then we will have a 3rd vector worksheet due on Wednesday. Do I have anyone who wants that 3rd vector worksheet today? Okay, I'll go ahead and have it available if you want the 3rd vector worksheet. If you get overwhelmed easily and want to leave it with me, that's fine too. No, there's 3 things due Tuesday.
Okay, both back.
Yes, because the little worksheet's 4 problems. I should have attached it to the back, but I wasn't smart enough to do that. But those 2 packets are due Tuesday, but the 3rd packet is due Wednesday. It's not really any harder. It's just broken up so y'all don't get overwhelmed. But some of you are overachievers and would like.
And you said that was due too.
Mm-hmm. And we have a quiz on Wednesday.
Oh, okay. Much less we can go and say.
On Wednesday? Okay. If y'all want to take the quiz on Tuesday, you can. I thought about making it on Tuesday, and I just couldn't do it after a 3-day weekend. I just felt, even I feel bad for you sometimes. So I decided to do it Wednesday just because of the 3-day weekend. But other than that, there's no reason you couldn't take it Tuesday if you want to get it out of the way. Or you can take it Thursday when you get back. So you've got options. I would think about not missing class on Thursday. We're doing a polar coordinate review, which is probably okay, but and then we'll start calculus with polar functions next Friday.
So what are we doing on Tuesday?
Tuesday we are working on vector worksheet 3.
Okay.
Right. That's why I almost gave the quiz Tuesday. The only reason you're not having a quiz on Tuesday is the 3-day weekend, and I felt bad for you.
Okay.
Do I need to make this a little bigger? I might do that. I'll see if I can. Is that good? Is that big enough? Hold on. Make these bigger too. I know you're not down there yet. Okay. So let's start with part A.
Okay, did just give me your because they give me a t equals 3 times 2 minus 1.
I would want a decimal. I would want to go to my graphing screen and get a decimal if I were you. Okay, at point C, dy dt is positive at is dy dt positive at point C? Is dx dt positive? Give a reason for your answer. Well, which way are we moving? We are moving left. And so at point C, we are going, sorry. So it says a particle starts at point A on the x-axis and goes from A to B, B to C, C to D. So at point C, would you agree I am moving left and down? So both dy dt and dx dt are negative. So the answers to both of those are no. No. Dy dt is less than 0. It's at C. The particle is moving down. It's probably a little overkill with the words, but that's okay. And then no, dx dt is less than 0 since at C, particle is moving left. Okay, the slope of the curve is undefined at point B. At what time is the particle at point B? Well, in other words, I want to know when dy dx is undefined, correct? So, I don't know what y prime is, right? Is this the problem I'm remembering? I don't know what y prime is. But when would dy over dx be undefined? When dx dt is 0, right? So I want to know dx dt equal to 0. For AP purposes, it's fine if you don't write out the function. If you write dx dt equals 0, that would be plenty. And so I want to find that. I would not recommend using the solve button in the TI-89 for this. I would recommend using the graph screen in either calculator. Have y'all ever seen me find a 0 in the TI-89? Okay, let's do that. Will someone let me borrow yours? My TI-89 is ancient. Not that it's different, but just in case. Okay, so in the TI-89, I'm going to go to diamond y equals, and I'm going to type dx dt. What is dx dt? Will someone... And I'm going to do this not in parametric format. So I'm going to change my mode back to function format. I just want, and I am going to change it also to radians. Radians and function. Because I just want to solve the equation, right? The way I always solve equations. And so what was the function? I don't know. I will. -9 cosine of pi t, so I'm going to use pi x, over 6, close parentheses, times sine of pi times the square root of t plus 1, so I'm going to do x plus 1, close parentheses, divide by 2. Does that look right? And then I'm going to go to the graph. I am going to go look and see if it gives me any. So we have t greater than 0 and t equals 9 is the final position. Why did I go look for that really quick? Why would I do that? Why do I want to know where my t's go from and to? Good. Aren't there infinitely many times that that equation equals 0 probably, since it's cosine sine function? So I don't want to have to look infinitely, so I'm going to look from 0 to 9. My x's, which, remember, my x's were t's, so I'm going to set my x min and...
So we can see that on the screen right now.
Oh, yeah, sorry. I'll pull it up. I hid it because... Okay, so this is the graph from 0 to 9. I do want to know when it equals 0, correct? Everyone agree with that? So I'm going to go to I'm going to go to F5, 0. You could use the intersection button very similarly to the 84. I'm going to go to the left of the 0. It looks like there might be one right here, so I'm going to go to the left of that. And then I'm going to go to the right of that. And I'm going to push enter. 3. And then maybe again over here at like what looks like 9, we'll find out and we'll decide if we need to include that or not. We'll go read the question a little closer. I might have to move my window to be able to tell. Again, there's nothing fancy about the 89 compared to the 84. You could do this exact same work in the 84. So at 9, there is also a 0. Now, I am looking for B. Is B the final resting place? That is what it's asking, right? What's the coordinates for B? So I would say I don't care about the 9. Does everyone agree with that? So, what time is the particle at B? T equals 3. Do what? Okay, good question. I do want to find the point B, so I have to use a little bit of logic here and go look. Remember it said at time 0 I start and I stop at time 9. Isn't D when I stop? Right, so D is at time 9. So I'm obviously looking for the one before that happened. So that would have to be at time 3. At time t equals 3, therefore dy dx is undefined at t equals 3. So this didn't say justify, so I'm not going to use lots of words, but I am going to let them know what I did and why I did it. I set the dx dt equal to 0, and I did that because I wanted to know when dy dx was undefined. Have we done a tangent line problem on vectors, which we did them on parametric, so practically we have. I don't know if we've done one on... Okay. The tangent line to the curve at 8 has at time 8 has this equation. Find the velocity vector and the speed of the particle at this point. I could easily find dx dt, right? That's it. In fact, I just have to plug in 8. I've got it. Everyone agree with that? What do I not know? dy dt. But I do know that dy dx is defined to be dy dt over dx dt. Everyone agree with that? At time 8, dx dt is, someone go find that for me really quick. It's in your y1. Actually, it's in my y1. So I want the y value, or the, at 8, yeah, negative 4.5. So this is negative 4.5. What what should those divided equal at time 8? Yeah, time 8, that should equal 5/9. Could I solve for dy dx? Multiply by negative 4.5? 5/9 by negative 4.5? Is it? Okay, I'll take your word for it. Oh, and I have a typo there. That's a dx, not a d, or a dt, not a dx. I said it right, but I didn't write it. So dy over dt is negative, did you say negative 2.5? At t equals 8. So the velocity vector at time 8, remember I only want at time 8, is negative 4.5, negative 2.5. Everyone agree with that? And then how would I use that to find the speed of the particle? Plug it into the speed formula, which is the square root of 4.5 squared plus, and you notice I left the negatives off, but it's because of the square. So that is the speed. Okay, I'm going to let you finish that. I'm going to go through the next one. How far are points A and D, the initial and final positions, respectively, of the particle? How far apart are they? So what is that another, if I'm asking how far apart, what kind of question is that? Distance. So I'm going to do the integral. Okay, any questions so far? I'm going to stall for a moment and let you think. Formulas memorized by Wednesday. Unless you are taking the quiz early, then Tuesday. Okay, now, what I want you to know, we are trying to find distance, right? Picture's a good idea. Question. Do I want the total distance the particle traveled, or how far apart? Okay, is that a different question? Okay, total distance traveled would be the integral from 0 to 9 of the square root of x prime squared plus y prime squared, right? And that would be a big problem. Why would that be a big problem? We don't have y prime. So I hope that's not the question, right? It's not, is it? I want the distance here, right? I can't draw a straight line, sorry. So I just want the distance from D to A. Would you agree that would only be an x distance since they both sit on the x-axis? So that means all I need to do is the integral of x prime of t to get distance from time 0 to 9 of x of t. Yes. Say that again. Y of 1?
Yeah, y of 1.
To type y parenthesis of 1. Yeah. On the TI-89 calculator, if you want to type y of 1, you just type y parenthesis 1. Okay, any questions about that so far? You have a calculator, you could type that in. Got some options.
So on the formula that you gave us, we have V1, I think it is, plus V2. Is that just the same thing, like for distance?
No, okay, so distance traveled, total distance traveled is this guy up here. And so at first glance, I thought I might need to do that. But that would actually give me all of this stuff. And I don't really want that. All I really want is A to D. So that's good news because that would be
Okay, and that was the one that says displacement on the one that we got.
the what?
On the equation.
Yes, because I want the displacement from.
Okay.
I only want the displacement on X, not X and Y both. Okay, and just mental note, you can type that in your calculator, can't you? That thing we just did, so I think you can do that. Mental note, here are the y1 of, you don't have to type of X, you can type y1 of, you can type y1 of 1. Like y1, sorry, yeah, you do need the 1. Did I just say y? You do need the 1. y1 of 2, I don't, whatever you need, whatever you're looking for. Okay, this is the AP rubric for this problem. You got 2 points for part 1, not positive with reason. Sets dx dt equal to 0, gets the 3, that's 2 points. 3 points on part C, a point for x prime of 8, a point for y prime of 8, and a point for the speed. And then the last one, you get a point for the integral and a point for the answer. So they are 39.255. Did y'all get 39.255? Perfect. AP doesn't care how you get this. Okay, any questions about this? Did this help with any homework problems we were stuck on? You didn't get the same answer? Come show me. We'll look. Okay, remember the schedule at worksheets 1 and 2 are due Tuesday, worksheet 3 due Wednesday. Tuesday will be a work day, Wednesday will be a quiz day. I will also give you your polar review assignment on Wednesday, so if you wanted to work on that on Wednesday, you could start. Make sure you have the formulas memorized by Wednesday.